This episode of SciShow Space is sponsored by Magellan TV, a documentary streaming service founded by filmmakers. SciShow Space viewers will get a 1-month free trial on Magellan TV by clicking on the link in the description. Even if you feel like you're standing still on the surface of Earth, you never really are. Our planet is spinning and it's orbiting the sun, but the entire solar system is also hurtling through the galaxy, orbiting the supermassive black hole at its center. And while most of us are thankful that we can't feel these dizzying motions, some scientists are hoping to use our galactic flight to help detect some of the most elusive particles of all: dark matter. Interstellar space is far from empty. In fact, it has some particles that are potent but invisible, like dark matter. And although we have not seen it, Earth might be experiencing some of it as headwinds. You see, as a solar system, we are whirling around the center of the galaxy at a whopping 220 kilometers per second. Adding all of these motions together, the Earth is moving fastest through the galaxy during June, when the planet's orbital motion aligns with the sun's motion through the Milky Way. Whereas in December, the Earth is moving backward compared to the Milky Way's spin, kind of like swimming against the current, so our overall speed is at its lowest. Luckily for us, most other things in the Milky Way are also wheeling around the galaxy at a similar rate, so we're not in much danger of barreling into another star or planet. But although it might seem like a black void, we might be plowing through a lot of dark matter. Now, dark matter is thought to outweigh normal matter by about 6 to 1, but we've never managed to pinpoint the particles responsible for it. Something powerful but invisible must be exerting a force on the stars orbiting in galaxies, or else those galaxies would fly apart. So it's thought that there is a shell or halo of dark matter that sits like a cloud over the galaxy, providing the gravity needed to keep those stars in check. If that's correct, then as we orbit the Milky Way, we are plowing through this dark matter slightly faster in June than in December, and the Earth is experiencing like a dark matter headwind as it travels. Compared to the motion of the stars and planets, dark matter is pretty much static, so the strength of the headwind we experience depends on the speed of Earth at any given time. So like when you stick your hand out of a car when you're driving along, you feel a wind from all the air molecules your hand is hitting. The faster the car, the faster the wind feels. So as the relative speed of the planet changes through the year, so too does the strength of the dark matter headwind, meaning that we should experience more of that headwind during June, when we are going the fastest, and less in December, when we are at our slowest. And now, an experiment deep in the Italian Apennine Mountains claims to have detected this variable headwind signal, with exciting implications for the detection of dark matter, too. The experiment, named DAMA, has been running in the Gran Sasso National Laboratory in Italy for about 20 years. They use crystals of sodium iodide doped or impregnated with thallium. These crystals are often used to detect radioactivity in lots of different scientific fields like medicine, geophysics, and nuclear physics. So when any subatomic particle or strong electromagnetic radiation strikes these crystals, they absorb that radiation and release the excess energy as a photon, which we see as a flash of light. The tricky part here is that Earth gets lots of radiation from things like the sun and space in general, so researchers had to prevent all of the other sources of radioactivity from getting into the crystals. So as you can imagine, they are heavily shielded. The crystals are engulfed in a pure nitrogen atmosphere surrounded by thick layers of copper, paraffin, and concrete buried under nearly 1.5 kilometers of overlying rock. And even with all these protective layers, the crystal detectors still emit light, a signal that rises and falls over the year, with more flashes in June and fewer seen in December. Kinda on schedule with the projected headwinds. So if the shields can block out all known particle bombardments, then the scientists conclude that the variable signal they are detecting must be coming from something we have not yet seen and accounted for. The best candidate for that is the dark matter headwind. After 20 years of measuring, the team is certain that their signals are real and not random background noise. But confirming the detection of dark matter is not so straightforward. There's a bit of controversy surrounding this result. Many scientists are skeptical that the annual signal is really coming from beyond the solar system. Some suggest it could be from something unaccounted for that changes with the seasons and not with the headwinds per se. And other similar experiments have failed to find the annual variation at all. But a new project on the other side of the world hopes to combine its results with DAMA to test the galactic headwind hypothesis once and for all. It's called SABRE, and it is located at the bottom of an active massive gold mine in southeastern Australia. The experiment will use the same setup as DAMA and hopes to find the same annual variation that the Italians have detected. But the timing of that rise and fall will be critical, given that this other experiment is in the southern hemisphere. If the detectors peak during the Australian summer in December, then it is likely that the annual variation is down to the changing seasons. But if the detections peak in June, as it does in the Italian experiment, then it is more likely to be caused by something beyond the Earth, like the dark matter headwinds. And if they don't detect any annual variation at all, well, then it will be back to the drawing board. Solving the mystery of dark matter is never gonna be easy, but these cutting-edge experiments are showing the power of thinking outside the box, or at least outside the solar system. Thanks for watching this episode of SciShow Space. If you want to learn more about the mysteries of dark matter, check out today's sponsor, Magellan TV. Magellan TV is a documentary streaming service founded by filmmakers, so they have a bunch of high-definition content that goes in-depth on different science topics like space, technology, nature, and more. For example, they have a whole hour-long documentary on the mysteries of dark matter, where you will learn more about the scientific quest surrounding this strange, unknown substance. So if you like space as much as we do, we know that you'll like this one. The best thing is, they can be watched anytime, anywhere on your TV, laptop, or mobile device, so click the link in the description for your first full month for free.